The ambiguous case has to do with solving triangles, and it potentially occurs when you're given angle side of a triangle. So I wrote out some stuff. This is the standard way that we would label a triangle. You would use capital letters to label the angles, and you would use lowercase letter, the same lowercase letter on the side opposite the capital letter to label the side. So lowercase a, b, and c are the lengths of the sides, and uppercase a, b, and c are the angles involved. So the ambiguous case potentially occurs when you're given angle side. And I drew some stuff out already. Angle A is known, side C is known, side A is known, but I didn't draw side A because angle B is unknown. So we don't know if side A goes like this, or if it goes like this, or if it goes straight down. We just don't know which direction it goes in, so I'm unable to draw it because it may not be correct if I drew it right now. So this is angle side, but this side is unknown. And I wrote B is not known here because I think that's a crucial piece in understanding this presentation about the ambiguous case. So let me ask you, how long would side A have to be in order to make a triangle? In order for there to be any triangle at all? Well, we know that side A starts here at this point B. That B, it represents the angle there, but loosely it can also represent the point. So at point B, we know that's where side A would start, or the segment A would start. But how long does that segment have to be in order to make a triangle? Well, that segment would have to reach to side B down here. And side B, we don't know what the length of side B is, but we know that it's somewhere on this dotted line. So what it boils down to is it would be the altitude of that triangle. And we know that the shortest segment between a point and a line is the segment perpendicular to the line going through that point. So I'm going to draw that in. And that segment is perpendicular. So I'm going to draw it. That now is a right triangle. And I'm going to label that H for height. So if we can figure out what that height has to be, that's the shortest length that A could be in order for there to be a triangle. So, and we can figure that out because we know that sine of angle A equals opposite over hypotenuse. So that's H over C. And multiplying both sides by C, we get H equals C sine A. So I'm going to say equals C sine A. So this is the shortest side A could be, C sine A. That's the shortest side A could be in order for there to be a triangle. So let's consider the what ifs. What ifs about A and comparing it to C sine A. So if A is less than C sine A, then no triangle is possible. And let's see how that would work. If this is this length, the height is C sine A. So if A was shorter than that, we wouldn't have enough, it wouldn't be long enough to make a triangle. So that's the case where no triangle is possible. Then if A is equal to C sine A, that means that A is exactly that length, and there's one triangle possible. That triangle is a right triangle. Then another case is if C sine A is less than A, and A is less than C. So A is between this length and this length. So we can do that as an example like this, and I could swing up this way and there'd be a triangle. Or I could swing this way and there'd be another triangle. So that's where two triangles are possible. And that is the ambiguous case. It's ambiguous as to which triangle is represented. So I'm going to star that as the ambiguous case. And then we have another case where A is greater than or equal to C. And if A is greater than or equal to C, then you can see that, like, this is right about equal to C, so that's greater than or equal to C. You can see that we could swing it up this way and it would make a triangle. But if we swung it this way, if it's equal to C, the sides would be laying on top of each other and there is no triangle. If it's longer than C, then it would go up this way, and now angle A isn't even part of that triangle. That triangle is over here. So only one triangle would be possible, and it would be an acute triangle. So I hope that makes sense, because that's really in detail exactly how you would think through these types of problems and think through what the possibilities are. Now let's do a specific example. And the most interesting one is the ambiguous case. So I'm going to let A equal 30 degrees, capital A, so that's the angle A is 30 degrees. C equals the square root of 3. That's the length of this side, C. And A equals 1. So what we want to do is compare A to C sine A. So we want to compute what C sine A is, because A would have to be at least as long as C sine A and not as long as C. So we need to compute what C sine A is. C is square root of 3. A is 30 degrees. So this is equal to the square root of 3 over 2, because sine of 30 degrees is 1/2. So root 3 over 2. So A would have to be at least this long, and square root of 3 is about 1.7. And 1.7 divided by 2 is about 0.85. Oh, 1.7 divided by 2 is 0.85. Root 3 divided by 2 is approximately 0.85. A is longer than 0.85, so we know we have at least one triangle. And A, which is 1, C is the square root of 3. A is also less than the square root of 3. So we know that two triangles are possible because of, how I swung this up before. We'd have one, that would be, this angle would be an acute angle in that case. And the other one's over here, this angle would be an obtuse angle in that case. So we know we have two triangles. So I'm going to draw both of those triangles and label them as much as I can. This one is where that would be an obtuse angle here. And we know A was 30 degrees. And we know side C was the root of 3. And we know that side A is 1. So we'll use the law of sine here to solve for this angle, angle C. And I'm going to draw the obtuse case, or this is the obtuse case. I'm going to draw the acute case also. So we'd have and in this case, A is still 30 degrees. Make a degree mark here. C is the square root of 3. And A is 1. And this is angle C. So we're going to figure out angle C in both cases. And I'll start with this case. So we have sine of 30, using the law of sine. Sine of 30 degrees over 1 equals sine of c divided by the square root of 3. Sine of 30 is 1/2, so if I multiply both sides by root 3, I get sine c equals root 3 over 2, or c equals arc sine root 3 over 2. Now I'm going to do the same exact thing for this one. So we have sine of 30 over 1 equals sine of c over root 3. Hope you've noticed they're looking pretty much the same. And that's how multiplying both sides by root 3 and sine of 30 is 1/2. We get sine c equals root 3 over 2, or c equals inverse sine of root 3 over 2. But wait a second. I got c equals arc sine of root 3 over 2, and c equals arc sine of root 3 over 2. It sure seems like, I mean, it looks like c is the same angle, so how can one of them be obtuse and one of them be acute? Well, arc sine of root 3 over 2 is 60 degrees, so c equals 60 degrees. That makes sense for this acute triangle. We have a 30, 60, 90. So it's a 30, 60, 90 right triangle, and C is a 60-degree angle. But what happened here? This one's obtuse, and we know that arc sine of root 3 over 2 is 60 degrees. So what's going on here? Well, what's happening is the range of arc sine is between negative 90 and 90. So arc sine will never output a value that's less than negative 90 or greater than 90. And we know an obtuse angle is greater than 90 degrees. So we want to appeal to the unit circle. And this is where I think you should have a really good understanding of the unit circle, because this will make perfect sense if you understand the unit circle well. If you don't understand the unit circle well, you'll probably be scratching your head a little bit. I think it'll still make sense. You'll think it through and it'll still make sense. But if you have an understanding like the one that I described in my video on the unit circle, this will just make perfect sense to you. And I think it should make perfect sense to you. So I'm going to draw a unit circle real quick. And the 60-degree angle would be right here. That's a 60-degree angle. The question is, what other angle would also have a sine of root 3 over 2? And that other angle is in the second quadrant. So remember, the sine of the angle is the y-coordinate where the terminal side of the angle intersects the unit circle. So it's the y-coordinate right there. And where else would there be a y-coordinate of that same value? Well, it would be right here. You just go horizontally, and the sine of this angle is also root 3 over 2. So it would be this angle. Or this is the reference angle. The reference angle is 60 degrees, so it would be 180 minus 60, and this angle would be 120. So here, C is equal to 120 degrees. So this would be 120 degrees, and if this is 120 degrees, this is also 30 degrees. And then since both those are 30 degrees, we know we have an isosceles triangle. So this length is also 1. Here we have a 30, 60, 90 right triangle, and we know that it's 1, 2, root 3. So we have both those triangles solved. So I really want that to make sense to you. I really want you to take the time to understand what's going on, because if you understand what's going on, you'll be able to field all sorts of questions. It won't matter what the question is, you'll be able to think through these problems. And as if you're at this level, you probably already know that the different problems just cover a really super wide array of circumstances, and you need to have this kind of a depth of understanding in order to field those questions. So, okay, I'm going to erase the board, and I'm going to show you the, once you understand all this stuff, of course there's a faster way to do things. There's always going to be a faster way. But the faster way is through understanding. It's not through memorizing a bunch of stuff, because we're all human, and it's just really easy to get confused and mixed up, as you know. But when you think about this stuff, just consider this, the quick way. I don't know how to do the quick way without knowing what you're doing, but this is what I would do. I would draw a triangle, label what we know. We know A, we know C, and we know A. So that's angle, side, side, that's what we know. And then I would use the law of sine to compute what big C is. So using the law of sine, we would get sine C over C equals sine A over A. And then we'd solve for sine C. So sine C equals C sine A over A. Now we look at this, and if this expression is greater than 1, then no triangle exists. No triangle possible. If this is equal to 1, equals 1, then 1 right triangle. If this is less than 1, then C is equal to arc sine of this value, but we'd also have to check to see if A is less than C. If A is less than C, then two triangles exist, and one of the triangles, C is equal to arc sine of that value. The other triangle, C is equal to 180 minus arc sine of that value. If A is not less than C, then only one triangle exists, and C, the angle C, is equal to arc sine of that value. And that's it. That's all you'd have to do. It's really quick and simple. You think it through as you go, and it's very simple to do, but everything that I discussed prior to this goes into being able to do that. So once you understand it, you can do it extremely quickly. But until you understand it, I think if confusion can ensue quite easily. And I think a lot of people have difficulty with this. So I hope that helps clear things up, and I hope you're able to do it. And again, any questions or comments are welcome. And thanks for spending the time listening.